Today, we start Module 3, Recursive Algorithms. We will have 4 parts. Part A, Introduction to Recursive Algorithms. 8.1, First View of Recursive Algorithms. First, we want to ask this question. Why recursive thinking is important in problem solving? Okay. Recursive thinking. Yeah. Because usually, if someone does not have the training in a class like this algorithm class, then it is not easy to get used to the recursive thinking. Yeah. So you need some special training to get used to it. Yeah. Because usually ordinary people, so they are used to straightforward thinking in problem solving. Straightforward thinking in problem solving. Yeah. So that's the non-recursive thinking. Yeah. So those people are used to step by step, okay? And directly. But there is a different, very powerful thinking, the recursive way. Yeah. So for this module, we will spend a lot of time to learn this recursive thinking. Yeah. All right. Some problems can be solved in both ways, non-recursive way and a recursive way. Yeah. Here we also want to compare in these two ways advantages, disadvantages. Yeah. So you cannot say one way is better than the other way. You have to consider the specific situations. In some situations, non-recursive way is better, and in other situations, recursive way is better. Yeah. So we need to understand that part. Yeah. All right. Yeah. Another thing we want to learn, power of recursion. Recursion way, very powerful. How much powerful? Yeah. So we need to learn that. Yeah. So one thing here I like to point out, some relatively hard problems can only be solved by recursion. Yeah. So why here I put a parenthesis around only? Yeah. Because sometimes in the textbook, or some, books, articles, people usually say any problem, if you can solve it recursively, then you can also solve it non-recursively. So you will see this kind of statement many places. Yeah. But based on our real world experience, it's quite different. Yeah. Because some of the difficult problems without using recursive method, you cannot imagine how hard to solve. So there are many problems like that. Yeah. For that reason, so here I put a parenthesis around only, yeah, because there is some, argument related to this issue. Yeah. All right. Next, yeah, we like to compare these two different ways, iterative way and recursive way. Here first, I just give you some, simple differences at this point. Yeah. So when we learn more, so we can have better understanding on these two different methods. Yeah. First, iterative way. So that's the non-recursive way. Iterative way, for loop, while loop, yeah. There is no recursion. So iterative way, advantage, less resource. Comparing with the recursive way, less resource. relatively less resource, but harder implementation, harder respect to hard problem. Yeah. Hard problem. Yeah. Some of the hard problems. Yeah. So more precisely, it should be some of the hard problems. Yeah. More precisely. Yeah. Yeah, because for some relatively easy problems, implementation not hard, right? Not hard. Yeah. Here we're talking about some of those really hard problems. Yes. Yeah. Recursively. Yeah. More resource. Why? So comparing the iterative, more resource. Yeah. To understand that, we need to get into the computer memory a little bit. Computer memory. Yeah. So when we run a program, so you need to use main memory, right? Yeah, you need to use main memory. All right, suppose this is the, memory space. So your program, your data, everything must be loaded into the main memory. Yeah. All right, so now for the recursive way, how to implement recursive function call in main memory. So it uses a very special data structure called a stack. I think in CS 2250, you learn this data structure, stack data structure, right? Yeah. So the recursive function is implemented by many levels in a stack. Okay? Yeah. If your recursive function is applied on a number or parameter with larger value, the stack could be very deep. The deeper the stack, the more resource is used. Could be very, very deep. So more memory space is used. For that reason, could be slow. So when you use a lot of resource, the program could be relatively slow. Yeah. So that issue you need to consider. Yeah. So that's the background behind this more resource. Okay. Yeah. All right. Relatively easier implementation. Yeah. For those hard problems, relatively easier implementation. Yeah. So later I will show you one example. So you will see the points we are discussing here. Yeah. All right, so now let's get into the questions. Let's get into the problem solving part. Yeah. We need to solve some problem, right? Yeah. All right. Problem number 7. Calculate the factorial. Calculate the factorial. Yeah. So you know the factorial. Yeah. Calculate the factorial. It's pretty easy, right? Everyone can calculate the factorial easily, right? Yeah. But using calculator, right? Or using some software tool. Yeah. But here we want to discuss the recursive implementation. All right. Find its factorial, n factorial, and you know the definition of the factorial. Okay? Yeah. So our first method, straightforward, iterative, one for loop, so simple. Yeah, you can do it easily, right? Yeah. For comparison purpose, so we still do it here. So first, we give the definition of the factorial. So that's the definition. Yeah. All right, but when we define the factorial function, It is a function of n. Yeah, it is a function of n. We may like to also define the factorial of 0. You may like it because sometimes in some special situation you may need it. Okay, here look at the definition of factorial of 1. It equals 1, not 0. Can you imagine that? Can you understand why factorial of 0 equals 1, not 0? Can you explain the reason? Right? It looks not that, straightforward, right? Yeah. It looks strange. How can you imagine 0 factorial? So you start from 0. Then you take factorial. You get 1. How can you imagine that? Yeah. Good. Yeah. We need to explain that. Yeah. We need to find a reasonable way to explain that. Yeah. Yes, because someone may ask you this question. How can you explain to your friends about this question? Yeah. All right. But I will give you the justification in the next slide. Yeah. So we will see that. Yeah. Pretty easy. Yeah. All right. So here, let's do the implementation. Just one for loop. So I do not need to write it explicitly. Yeah. You can do it easily. Yeah. All right. Now we move to method 2, recursive way. Recursive way. Completely different. Why? Because we can solve factorial problem using iterative method easily. Why should we consider recursive way, right? Why should we consider the recursive way? You will see it is important. The idea is important. The thinking is important. The recursive thinking is important. Remember the problem? So in some of my previous videos, I explained a problem is just a thinking method carrier. Here, this problem, factorial problem, is just another carrier. It carries this recursive thinking. Okay? So we use this to help us understand recursive thinking. That's the value. Yeah. All right, so let's look at the idea. So what idea we like to use in our thinking? Yeah. Here, we're talking about a general problem-solving approach. This very general problem-solving approach. Yeah. It is called divide and conquer. Divide and conquer. Yeah. I think you have heard of divide and conquer approach. Okay? Yeah. In our algorithms class, another extremely important thinking way, divide and conquer. Yeah. Actually, this one is our main topic, our topic in Module 4. Module 4. The whole module is about divide and conquer. Yeah. Because here, in this question, we need to use this thinking approach. So it's okay. We start here. We use it here. Yeah. In Module 4, we will spend a lot of time to learn divide and conquer. Yeah. All right. Next, how do we use the divide and conquer approach? Yeah. Here, I like to talk about the general principle when we use divide and conquer approach. In many situations, we can use divide and conquer. Yeah. But you need to understand the reason behind it. Why divide and conquer approach is so effective in so many problems. Yeah. Here, let me explain a little bit. First, we know this fact. So this is a fact. The problem is easier when the size is smaller. The problem is easier when the size is smaller. Okay? Yeah. That's true. Yeah. All the time. Yeah. All right. Number two, when you work on a problem of the current size, all right, so now we are working on the problem of the current size. Okay? Yeah. Whatever it is, assume that the problem of a smaller size has been solved. This is a big assumption. How can you assume that? How can you assume that the problem of a smaller size has been solved? How can you assume that? Yes, we can. We can assume. Yeah. In order to understand why you can, you need to recall mathematical induction. In Math 3000, you need to have that Math 3000 background. In Math 3000, you need to spend a lot of time learning mathematical induction. In mathematical induction, what is the induction assumption? Okay, induction assumption. So here, this part, just like the induction assumption, you assume that it's true. Assume it is true, but actually you can do it. Why? Because you can start work on base cases, right? Some small problem size base cases. Then you build up, okay? Gradually build up, increase the problem size one by one, right? Yeah, in that way, you can make legal an assumption like this. Okay? Here, I do not want to, talk about the mathematical induction things. Yeah. So we need to use that background. Yeah. All right. So we can do it. Yeah. It's legal. Yeah. All right. After that, there is a gap. Yeah. Because smaller size, current size, between these two problems, there is a gap. There is a gap thing. So you need to fix the gap through a recurrence relation. Yeah. Or we say bridge the gap. We build a bridge the gap. Okay? If you can build a bridge between those two problems of different sizes, you get a recurrence relation. So then you just write a program, implement, that recurrence relation, then you get problem solved. Yeah. So that is the, whole reasons behind this method. Yeah. Now, let's apply that logical reasoning on our factorial problem. Okay. So for this factorial, first, this is our current problem. So we want to solve this problem. So we define this problem, a function f of n, factorial f of n. The reason is we want to find the value of this function recursively. Okay? So we define a function so we can call this function recursively. Why you can call it recursively, don't worry. Yeah. The programming language supports the implementation of recursive function calls. So you don't worry. Yeah. The reason behind it, I drew that stack, right? That stack way, that's the implementation way inside your programming language. So you do not need to worry about it. You just use it. Okay. All right. So then, now, divide and conquer. So how do we divide? Okay, yeah. We divide the problem, cut the problem size somewhere to get a problem of smaller size. Here, we chop last number out. We chop it. Then this part, the problem of smaller size. Okay, f of n minus 1, the problem of smaller size, f of n minus 1. Then we just chop out one number out. Why? Yeah, that's one commonly used method. Just chop out one element. Why? Because in that way, this is the gap part. This is the gap part, gap between two problems of different sizes. When the gap is small, it is easier to bridge the gap, right? Yeah. So the logical reasoning is when the gap is small, here only one element, the gap is small, so then it is easier to bridge the gap between the differences of two problems of the same type with different sizes. All right, so that's the idea. Yeah. So now this is our recurrence relation. Recurrence relation like this. Okay? And here, when we use this recurrence equation, we need to put a condition n greater than 0. Yeah. All right, n greater than 0. Then we can use this formula. Yeah. All right, now it is the time to explain why 0 factorial equals 1. Why is that? Yeah, let me explain. Yeah. All right. So with this formula, we just derived recurrence relation for the factorial. Then we can write in this way, right? We can do the simple transformation to get this expression, f of n minus 1 equals f of n over n by simple algebra. That's legal, right? Because why it is legal? Because n greater than 0. The denominator is not 0, so we can divide it by a non-zero number, both sides of the equation. So we can do it. Yeah. Now, we plug in the n number, n equals 1. We plug in, what do we get? We get f of 0, yeah, 1 minus 1, f of 0 equals f of 1 over 1. F of 1, that is the 1 factorial. 1 factorial is 1, right? 1 over 1 equals 1. So now, from this expression, you see 0 factorial equals 1. So if you explain in this way to your friends, I think you will get a very good, understanding, yeah, for the justification, yeah. All right, yeah. The reference, chapter 4, page 131, yeah, in our textbook, yeah. All right, conclusion. Now we get to our conclusion. It is an interesting way to solve problems. Divide and conquer, recurrence relation, it is an interesting way to solve the problem. It is completely different from our iterative method, completely different. But it's a new thinking way. It is a valuable thinking way, and we will see the power of this new method, and we will make it as a powerful tool in our toolbox in solving many computing problems. All right, so let me finish the first video here.